Hi guys, welcome to this class, and today we are going to be talking about the mechanism of respiration. So before we proceed, I would like to advise you, if you know nothing about homeostasis and you know nothing about some respiratory organs, it's better for you to go back there and get a better understanding of those things. Example is the what? Is the lungs. Although I'm still going to bring this down to a general level of understanding, even a layman is going to understand. But it is advisable for you to go back and deal with all those things separate. So if you need a link to our private class, so you can just chat up a number that's going to be dropped in the description box where we used to check out our comments. So right there, you find a number there, and the number actually is going to lead you towards to our personal and private videos. So that being said, let's get started with what? With the mechanism of respiration. I'll be right back, guys. Yeah, welcome back. And now, talking about the mechanism of respiration. Mechanism of respiration. Mechanism of respiration. Now, mechanism of respiration, it revolves around three words. But the major words that we need are these. So the word mechanism and the word respiration. Now, what is the meaning of mechanism? We know that in anatomy and physiology, mechanism most of the times deals with homeostasis. Homeostasis. Now, in our homeostasis, we said it is the maintenance of constant, balance, or stable internal environment of an organism. And we said homeostasis presents with majorly three components. So we said the first component is what? Is the receptor. And the second one is the control center. And the last one is the effector. So that's why I said you have to have a knowledge of what? A sound knowledge of homeostasis before you understand the mechanism of respiration. So we said the word mechanism refers to homeostasis, right? And homeostasis has three components. So all these guys here, they are components of homeostasis. The components of what? The components of homeostasis. So, that being said, what about the word respiration? We know that the word respiration deals with breathing. But for the mechanism of respiration, what we are going to need majorly are the structures, which are the pleural cavity, or let's say the pleural membrane strictly. Pleural membrane. You are going to know about the lungs. So you have to know about the diaphragm. And you have to know about the intercostal muscles. Intercostal muscles. So you have to know about all these things right here for you to understand the mechanism of respiration. Now I said you have to understand that the component of homeostasis are the receptor, control center, and the what? And the effector. And then I said, under respiration, you have to have a glimpse of what these things are, what they mean. So the pleural membrane, what's the meaning of that? The lungs, what's the meaning of that? The diaphragm, what's the meaning of that? The intercostal muscle, what's the meaning of that? So you have to understand all these things. And now, this is just under anatomy and physiology. Now, under physics, you have to understand two laws. And those laws, they are going to help you while dealing with the phases of respiration. So the first law is the Boyle's law. The Boyle's what? The Boyle's law. And the second law is law of diffusion of gases. So, law of diffusion of gases. So these two laws, they are those things you need in physics to understand. Now, I'm not doing all these things to scare you. I'm just doing this for you to be prepared, for you to what? To prepare yourself and know what you're going to what you're going to get from this video. So from this video, you're going to learn a little bit about homeostasis. You're going to learn a little bit about all the structures of respiration. And you're going to learn a little bit about all these laws. And then we are going to implement that knowledge. So we are going to utilize that knowledge. So we are going to use that knowledge to do what? To tackle our mechanism of respiration proper. Now, let's get started. Talking about this homeostasis, this receptor, what are they? receptor is from the word receipt. So, and that is emanated from the word recipient. You see what? Recipient. So recipient is someone that receives a letter in English. So in English, we say recipient is the person receiving the letter. But here they are not receiving letter. On the other way around, they are receiving something called stimuli. So stimuli means changes. The singular is stimulus. And stimulus means a change. As simple as that. So that is the function of receptor. Their function is to detect change or changes. So they do what? They detect change. That is the function of receptor. Now, for the control center, their function is to regulate impulse. To regulate what? To regulate impulse. That's their own function. And what is the meaning of impulse? Impulse means a message. As simple as that. And finally, the function of this effector, most of the time, is to reverse change. Reverse what? To reverse a change. So, the word reverse change, this change is actually from this change that this receptor received. So, after this guy received the change, this guy is going to what? Is going to reverse it. For example now, if the change is increase in pressure, so this receptor is going to detect the increase in pressure, but this effector will reverse it by turning it into decrease in pressure. I hope you understand that. So they're like what and opposite. This one will detect it, but this one will reverse it. As simple as that. Now, let's talk a little bit about all the structures of respiration. So I'd like to wrap the board and come back. So, I'll be right back. Yeah, welcome back. And now, talking about the mechanism of respiration, we started with the homeostasis, which means mechanism. So we said homeostasis has three components. The first one is the receptor, second one is the control center, and the third one is the what? The effector. So we said the function of receptor is to detect a change, and the function of the control center is to regulate a message, an impulse, and the function of the effector is to reverse the change. Now let's talk a little bit about the respiratory aspect. We said mechanism of respiration. Now let's take a look at this diagram. Now, for us to understand very well, let me start explaining. This is not a right diagram for the nasal cavity. What I'm trying to say, what I'm trying to show in this diagram is that oxygen will pass in through this nose into this place, and then it can also pass through the mouth. So I'm using this portion here as what? As the airway, conductive airway. So then the air is going to pass down like this. The oxygen is going to pass like this into the what? Into the larynx here. From the larynx here into the trachea. From trachea into these two bronchi. And then it's going to rush into the what? Into this proper structure here called the lungs. So this structure is called the what? It's called the lungs. And now, this lungs is covered by some kind of layers. So now, it's covered by what? It's covered by layers. Now, you will realize that I used two different colors to indicate these two layers. But collectively, that is, these two layers together, so they form the membrane called the pleural membrane. The pleural what? The pleural membrane. So this pleural membrane is the one that houses, is the one that covers the what? That covers the lungs. So this membrane covers the what? It covers the what? It covers the two lungs. As simple as that. Now, what I want you to know is that this pleural membrane, it has two layers. It has two what? Two layers. And what are those layers? The first one is this red marker. So the first one that I indicated with this red marker, you can see that it is closely what? It is closely adhered to the what? To the lungs. So it adheres strictly with it. It sticks with the lungs. So this very layer, this innermost layer, the color red, it sticks with the what? With the lungs proper. So the black line is the lungs. You can see that they are very close. So that inner layer, it adheres to the what? To the lungs. And it is called the visceral pleura. Visceral what? Visceral pleura. Simple as that. But the one covering it, this blue one, that covers this one, it is the outermost layer like that. So, and it's called the parietal pleura. Parietal pleura. Now, a quick recap. We said these are our lungs. So I indicated them with the black what? With the black marker. And then I said they have a kind of membrane on top of them that's covering them. And the membrane is called the pleural membrane. So, and I said the pleural membrane, they have two layers. I mean, the pleural membrane has two layers. So the first one is the viscera here. So the visceral what? Pleural. I would say the visceral pleura, it sticks with the what? With the lung. It adheres with it. And then the one that is the outermost layer, so it's the what? The parietal what? The parietal layer. That is the second one, the second layer. I hope we understand that. Now, what we have to know after this, the point is that we have a space between these two layers. You can see this is the red marker and this is what? This is the black what? I mean the blue marker. So this red layer is the innermost layer and the blue is the what? Is the outermost. So between it, you see that we have a space there, and that space is called the pleural cavity. The pleural what? The pleural cavity. So it is from what cavity? Cavity means a space. So the space between the pleural membrane within what the pleural membrane is called the pleural cavity, and then it contains some fluid inside it. So, and those fluid are called the pleural fluid. The pleural what? The pleural fluid. So the function of this fluid is to prevent friction. Prevent what? To prevent friction. So you know that these two layers, they have the tendency of rubbing against one another. But because there is a fluid with between them, that's going to prevent them from rubbing together. So and if they get rubbed together, it can generate heat and cause some other conditions of the airway like pleurisy. So we talk about that in the pathophysiology. So yes, pathophysiology of the respiratory system. So we'll talk about that later then. So back to what I was talking about. The point is that these are the two lungs now. And these two lungs are covered by a membrane. And that membrane is called the pleural membrane. So the pleural membrane has two layers. The innermost layer is called the visceral what? Pleura. I indicated that with the red marker. And I said it sticks with what? With the lungs. It is closely adhered to it. And then the second layer here is the parietal pleura, and that is what? The blue marker. So it is the external layer or the outer layer. So this viscera is the innermost layer. And between these two layers now is a space actually, and the space is called the what? It's called the pleural cavity. And that pleural cavity has a space. It has some kind of fluid inside it, and that fluid is pleural what? Pleural fluid. And the function of that pleural fluid is what? Is to prevent friction. As simple as that. Now, let me add something to it. And that is one of the most important things. We said this visceral layer, it adheres strictly with the what? With the lungs. Agreed. Now, this parietal layer, it adheres with something else too. So, it's what? It sticks with something else too. So, this visceral layer, it sticks with what? With the lungs. But this parietal layer, it sticks with something called the inner wall of the thoracic cage. The inner what? The inner wall of the thoracic cavity. Or you say thoracic cage. Thoracic cavity. Now the question is, what's the meaning of that? I said this visceral pleura, it adheres with the what? With the lungs. But this parietal pleura, this outer one, it adheres or sticks with what? Inner wall. What's the meaning of inner wall? I'm coming there later. Of the what? Of the thoracic cavity. The question is, what is the thoracic cavity? So you can check that out in our videos, body cavities. So you can check it out. One of our previous videos. I'm sorry about that. So you understand what thoracic cavity is very well. But the point is, thoracic cavity is your what? It's your chest. So it's the cavity within your what? Within your chest. This is your chest now. Everything from here now, from this anterior part, so to the posterior part, everything like that. That's your what? That's your thoracic cavity. So the inner part of that thoracic cavity, it is possible for you to what? To dip your hand within your chest like that. So that's inner part of your chest. So the inner part of your what? The inner part of your chest. I'm not talking about this close. I'm just using this as an illustration. So the inner part of your what? Of your chest. That is the inner wall of the what? Of the thoracic cage. I hope you understand that. So, and that is where the what? The parietal pleura is sticking with, is adhering with. Now, let me illustrate that. Let's assume that we've used this part now, so we can't illustrate it here again. Well, I don't want the diagram to be messy, right? Now, the point is that your chest will be will just be like this. So this will be your ribs. So have some bands of muscles. So then you have your ribs. So ribs. So between these ribs are intercostal muscles like that. Intercostal muscles. If you've been with this channel from day one, you understand what I'm saying easily. So if I know it, I'm sorry about that. You have to check out our previous videos to understand this very well. So all these things right here, they are the intercostal muscles. And these guys here, they will be the ribs. Now, this is what forms your chest. So if you are touching your chest right now, what you are touching are these ribs and the what? And these intercostal muscles. I hope you get that. So this is on the outer part now. This part will be on the outer part like that. And now, this part will be the inner part. So this is the inner wall that we're talking about. This is the inner wall of the what? The inner wall of the thoracic cavity or thoracic cage. So this inner wall, this pleural cavity, this parietal pleura, that is where it attached itself to. With rather. So this parietal pleura, it strictly adheres with the what? With this thoracic cage, the inner wall of the what? Of the thoracic cage. So that is what I want you to understand from this thing. Now, let me quickly chip in some things actually. This guy right here, I said it is the lungs. And do not forget, in our first thing, I said under the respiration, you have to understand some things. I said one of those things is the what? Is the lungs. So are the lungs rather. So you've gotten that right here. And then I talked about the pleural cavity or the pleural membrane. So these are the pleural membrane. You know what it means now. So the pleural membrane is covering the lungs entirely. And then it has two layers. So another layer forms a membrane called the pleural membrane. So the layers are the viscera and the what? And the parietal. So we said the innermost layer is the viscera and it adheres with the what? With the lungs. And then the outer layer is the parietal pleura. And then it adheres with the what? With the inner wall of the thoracic cage. As simple as that. Now, I said that to understand what we call the intercostal muscles. Intercostal what? Intercostal muscles. So we've said that here. So these muscles right here, they are the intercostal muscles. So muscles between the what? Between the ribs. So all this structure now, they are the ribs. So all these dotted lines, I mean these shaded parts rather, they are the what? They are the ribs. Now the muscle within them, between them rather, this muscle now is between this rib and this rib. And because it's between, the word between means inter, and the word rib means costal. So because they are muscles, you have that one to be clear that. So the intercostal muscles, they are the muscles between the what? Between the ribs. As simple as that. So these muscles are intercostal muscles. And what I want you to know is that this muscle, coupled with another structure called the diaphragm. Diaphragm. They are the major muscles of respiration. Major what? Major muscles of respiration. So we have other muscles of respiration like the scaling muscles, the abdominal muscles. But the major muscles of respiration are the what? Intercostal muscles and the diaphragm. Now, you know what intercostal muscle means. Then what about the diaphragm? So the diaphragm is just right here. Now, this dark portion that I just bring in is the diaphragm. The diaphragm. And you will realize from this diagram that these two lungs, they are sitting on it. So the diaphragm is a what? Is a muscle of respiration on which the lungs are what? Are sitting. And if you notice this, the shape is what? It is dome shape. Dome means like this, something of this nature. And that is the shape of your diaphragm. If you take a careful look at it, can you see? So That is the shape of the diaphragm. It is also a what? A muscle of respiration. And now, since we've established all these now, and then I want to be sure that you have a grounded knowledge on what on all these guys rather. So let's move to what we call the mechanism of respiration proper. So I will explain the Boyle's law and the Charles law. I mean the Boyle's law and the law of diffusion of gases along the way. So I would like to drop the board. Before that, a quick recap one more time. We said you have to understand what we call the lungs. So these are the lungs. Their function is to receive oxygen, right? So from the video of the lungs, you understand that it contains alveoli that does that actually. So that do that, sorry, alveoli is the pleura. So we said these lungs are covered by what? By the pleural membrane. After the pleural membrane has two layers. We have the visceral pleura, which adheres with the what? With the lungs proper. And then we have the external layer, which is the what? Parietal pleura. And it adheres with the what? The inner wall of the thoracic cavity. And then we said the intercostal muscles and the diaphragm. So we said they are the what? The major muscles of respiration. Your intercostal muscles, they are between the ribs. And then the diaphragm is actually below the lungs. As simple as that. Now, let's start with the mechanism of respiration. I'll be right back. Yeah, welcome back. And now, let's proceed with the mechanism of respiration. Now, mechanism of respiration, I used to liken it to a balloon. Mechanism of what? Of respiration. So if the question says, discuss the mechanism of respiration, maybe 8 marks, 7 marks, or 6 marks, the first thing you're supposed to do is to define it. And now, how do you do that? I used to use a balloon to define the mechanism of respiration. Now, if you have a balloon now, if you inflate it, that is, you are rushing air into it. So you are doing what? You are rushing air into it. Tell me, what will happen to that balloon? What will happen to its size? It will expand. It will do what? It's going to expand. So expansion. So it's going to expand. Why? Because you are rushing air into it, right? And now, let's assume that this is the knee size. Then the volume of that balloon has increased. As simple as that. But now, if you want this balloon, if you want to deflate it, if you want to reduce its size, what are you going to do? Are you going to press this place? You compress it. You squeeze it. You do what? You squeeze it. And once you squeeze it, what is going to happen? All this air will do what? They will rush out back. So, the air will rush out back, and the shape will become like this again. As simple as that. So, it has contract like this. So, contract also means squeeze. I hope you understand. Now, from this, how can you define your mechanism of respiration? Just look here. Take this balloon as the what? As the lungs. So if these balloons are the lungs, you can start defining your mechanism of respiration from here. So just say the mechanism of respiration is the process of what? Of expansion. So you are pulling in oxygen. So it's the process of what? Of expansion of the what? Of the lungs due to the intake of what? Of oxygen. So the process of what? Of the expansion of what? Of the lungs due to the intake of what? Of oxygen. So, and then what will happen next? And what? And the contraction, squeezing of the lungs. Now to do what? To bring out CO2. So once you squeeze this, it will bring out CO2 out. As simple as that. If it is the lungs. I hope you get that. So what the definition is telling you is that your lungs will expand when you take in oxygen. But what? Your lungs will do what? It will contract, it will squeeze out. When you do what? When you breathe out CO2. And that is the simple definition for what? For mechanism of respiration. That is the first thing to do. So, you said, it is the what? The mechanism of respiration is a process. So, which involves the what? The expansion of the lungs to take in oxygen, and the what? And the contraction of the lungs to take out what? CO2. As simple as that. Now, what next? The next thing I'm meant to talk about are the phases of respiration. Phases. So, mechanism of respiration, it has 3 phases. The first one is the inspiratory phase. Inspiratory words, inspiratory phase. And the second phase is called the expiratory phase. expiratory phase. And the last phase is called the pause. Now, what's the meaning of all these guys here? We are going to start explaining with the inspiratory phase. So, and then we go to the expiratory, and finally we finish at the pause. Now, the inspiration may look a little bit difficult, but trust me, it is not. So just stay with me, you are going to understand very well. And now, we have something else. Do not think because inspiratory is a little bit complex, the expiratory will be difficult. No. Once you've known this inspiratory phase, all other phases will become easy for you. So where we need to do a big work is this inspiratory phase. So I would like to drop the board and get started with it. So I'll be right back. Yeah, welcome back. And now we're starting with the what? With the inspiratory phase of respiration. Inspiratory phase. Inspiratory phase. Now remember, at the beginning of this tutorial, I told you that you have to understand something called the hemostasis. I would say the hemostasis has three components. We have the receptor, we have the control center, and we have the effector. So that is what we are going to be using to describe the inspiratory phase. Now, for us to understand better, I would like to illustrate the diagram of inspiratory phase. Now, let's get started. Good. Now, for you to understand the inspiratory phase, you will need a combination of all these structures right here. So I have to add some other structures there, but I will do that as we proceed on. Now, do not forget, I said mechanism of respiration is more of what? Of homeostasis, right? And I told you that homeostasis has three components. The first one is the receptor. And now remember, I said the function of receptor is to detect what? Stimuli. Stimuli. And we said stimuli means a what? A change. Now the question you should ask yourself is that what is the change in mechanism of respiration? The question you should ask yourself to know the answer to this is that what is the function of respiration? The function of respiration is to breathe in oxygen and then to breathe out what? CO2. Now careful. To breathe in what? Oxygen. O2. And breathe out what? CO2. And tell me, if you've been following this class on respiratory system, you already know that these O2 and CO2 collectively they are found in the what? In the blood. CO2 and what? And O2. That's oxygen that you are breathing in. They are coming back to your blood later. So the oxygen is coming into your what? Into your blood later. And then it forms CO2. So I'll use this medium to tell you about the cause again as well. So the point is that for us to get a better understanding of this, you have to take our course on respiratory system. So it's one of our private courses. So if you need access to it, just check out the number in the description below. I'm going to have a full access to all our respiratory system. Not only the respiratory system, but also other courses you can find available on our YouTube channel. So feel free to do what? To chat us up and ask for your own. As simple as that. Now, back to what I'm discussing. Now, we said the oxygen we are breathing in is going into the what? Is going into the blood, right? If that be the case, the change that used to occur in inspiratory phase is a reduction in that level of what? In that level of oxygen. So the oxygen in your blood, it has to have some kind of certain amount. Like let's say 10 for example. So if it is below 10, what is going to happen is inspiratory phase. So the word inspiratory phase is from the word inspire, which means to breathe in. So whenever you have a low oxygen level in your blood, so you are going to be what? You are going to be subjected to this phase so that you can breathe, you can inspire in more oxygen. I hope you understand that. Now, to start your inspiratory phase, we said the change that's going to occur is what? A reduction in the level of oxygen. Now you ask yourself, why am I drawing the heart? I'm drawing the heart because I need this structure right here. And this structure is called the aorta. But this place is called the arc of aorta. This arc of aorta, it bears or it has some receptors there. And those receptors are called chemoreceptors. Chemo what? Chemoreceptors. So the function of this chemoreceptor, they are the receptor that we're talking about in hemostasis. So these chemoreceptors, their function is to detect what? A change. And what is the change they are detecting? They are detecting a reduction in the level of oxygen. As simple as that. So you can start your respiratory phase with that. That whenever there is a drop or a reduction in the what? In the level of oxygen within the blood, what is going to happen? The chemoreceptors on the what? On the arc of aorta, they are going to do what? They are going to detect the change. They are going to do what? They will detect that change. And now be careful. These chemoreceptors, they are not only found on the arc of aorta, they can be found in capillary beds as well. But majorly, they can be found in the arc of aorta and the carotid artery. So, those are the major two places that you can find them. The carotid artery and the what? And the arc of aorta. Why? We'll talk about that some other time. Now, why not in the hepatic artery? Why not in the renal artery? Just keep on following us. You understand all this thing very well. Now, back to what I was discussing. Now, a quick recap. We said the word inspire means to breathe in, right? And if you breathe in, you are breathing in oxygen. It means you'll be adding oxygen to your blood. But for this respiratory phase, the stimuli, we said we are going to use homeostasis to describe it. The stimuli is that there is a reduction, the change, there is a reduction in the level of what? Of oxygen. And then, when that happens, you start picking your components. That the receptor, which kind of receptor? The chemoreceptors. They are going to detect the what? They will detect the change, and that change is reduction in oxygen. And once they do what? Once they detect that, they are going to send a message. Message means an impulse. They will send the what? A message or an impulse. Impulse is the anatomical term. But really, impulse means message. Do not disturb yourself. So they are sending a message to which structure here? The brain. Now the question is, which part of the brain? That part of the brain is called medulla oblongata. Medulla what? Medulla oblongata. Now this medulla oblongata, what is the function of this guy in the respiratory system or in the mechanism of respiration? It is the respiratory center. Respiratory what? Respiratory center. Which means it is the control center like that. The control what? The control center. What is the meaning of that? Come back to this hemostasis. I said hemostasis has three components. I said the first one is receptors. And the function of receptor here is that they are going to detect the reduction in oxygen level in the blood. And they will send an impulse to the what? To the what? To the medulla oblongata. And I told that the second component in hemostasis is control center, CC. So, the control center, we said it regulates impulse, right? And that is what this guy will do. So this impulse that has been sent to this medulla oblongata in the brain is going to do what? It's going to regulate that impulse first. Regulate the what? Regulate the impulse. And after that, what is going to happen? This medulla oblongata is going to send an impulse to somewhere else. Now, where is that place? And that is the next thing I will add to this diagram for you to understand. The next place is sending an impulse to right here. I told you in the previous thing that these lungs, they are sitting on what? On a structure that is dome-shaped. And we said that structure right here is called the diaphragm. The what? The diaphragm. Diaphragm. That is one. Now, two. The impulse will still come on some guys here. Sorry. Now, this is your chest. If you touch your chest like this, what you're touching here is what I want to illustrate for you here. Now, this your chest is made up of ribs. You can feel it yourself. So I will denote those ribs, those bones. I will denote them with just a shaded circle. So these dotted lines, they're the what? They are our ribs. The one you are what? The one you are feeling. And now between those ribs, we realize that after each rib, we are touching something like I don't know how to describe it, but we know that after a rib, the next thing you are touching is not a rib, something like a groove, like a hole. So those things, they're actually some muscles in our body. So those muscles are found between the what? Between the ribs. And because those muscles they are found between the ribs, in anatomy, the word between means inter. Within is intra. We'll talk about that later. So they are called inter, between. And now they are between what? They are between the ribs. And the word rib in anatomy means coast. So coastal. And because they are muscle, their name is intercostal muscle. As simple as that. So these trias, this line here, is an intercostal muscle. This one, another intercostal muscle. So this is also an intercostal muscle, an intercostal muscle, an intercostal muscle. Because those muscles are found between the what? Between the ribs. Same thing to the side too. And now, why are we talking about this? We are talking about it because of what? Of this mechanism of respiration. Now, we'll start all over again. In the inspiratory phase, there's going to be a reduction in the level of oxygen. And then the chemoreceptors on the what? On the arc of the aorta and maybe the carotid artery, they are going to do what? They are going to detect what? That stimuli, that change. And the next thing, they are going to send an impulse through the afferent pathway. If you know, if you watch our video on hemostasis, you will understand what I mean by that. Oh, I think it's part of our private course actually. So you can DM for it. Now the point is that it's going to send an impulse to the what? To the what? To the brain. But which part of the brain is sending an impulse to the what? To the medulla oblongata. So the medulla oblongata is one of the respiratory centers. Don't forget, I said one of, even the pons alveoli is there, but how is under coordination, nervous coordination. We'll talk about it later. Under inspiratory phase, this is what you need. So in the inspiratory phase, we said there is what? The stimuli there is what? The change there is what? Reduction in the level of oxygen. And then it is going to be detected by a receptor. And that receptor is called the what? The chemoreceptors. So the chemoreceptor can be found on the what? Arc of the aorta and carotid artery. So and then they are going to send an impulse to the what? To the brain. But which part of the brain? The medulla oblongata. So the medulla oblongata in turns now is going to do what? One, it will regulate the what? Regulate the impulse. Now, two, what is it going to do? It's going to send an impulse through some nerves. So, it's going to send an impulse through some nerves. This nerve that is coming down here is called intercostal nerve. Intercostal what? Intercostal nerve. Now, you can guess the function of intercostal nerve yourself. This function of intercostal nerve is to supply the intercostal muscle. The intercostal nerve is coming to meet the intercostal muscle. So, intercostal nerve, one of the mistakes to make is they think it's just one nerve. It has branches. So, intercostal nerve is going to branch like this. So, and it's going to be acting directly on the what? To be acting on the what? To be acting on those muscles. So, the intercostal nerve is coming to act on the what? It's coming to act on the intercostal muscles. And now the question is, what is the intercostal nerve? What is it going to tell the intercostal muscle? It's going to tell the intercostal muscle to do what? To contract. And now, what's the meaning of that? I'll tell you later. Now, a quick recap. Reduction level of oxygen will make this chemoreceptor to detect that change and send an impulse to the what? To the medulla oblongata. One, medulla oblongata will do what? It is going to regulate the impulse. And then it is send another impulse through this intercostal nerve to the what? To these intercostal muscles. Right? Good. And now the second thing is that it's going to send another nerve. And that nerve will come downward again and to act on this guy here. And this structure is what? The diaphragm. So the name of the nerve acting on the diaphragm, this nerve is called the phrenic nerve. The phrenic what? The phrenic nerve. Some textbooks they will call it diaphragmatic nerve. It's still correct as well. They call it diaphragmatic nerve because it's acting on the diaphragm. Just like the intercostal nerve is acting on the what? Intercostal muscles. As simple as that. Now, What will happen next? I will tell you that in the next thing. But before that, let's do a quick recap. We said for the inspiratory phase, there is a reduction in the level of oxygen, right? And after that, we said, using your knowledge of homeostasis, receptors called the chemoreceptors, they will detect that change. And they are mostly found in the arc of aorta and the carotid arteries. And then they are going to send an impulse to the what? To the medulla oblongata. And medulla oblongata will regulate the impulse, 1. And 2, is going to send impulses through the what? Through these 2 nerves. Intercostal nerve will act on the intercostal muscle. And then the phrenic nerve will act on the what? On the diaphragm. And now, what are these 2 guys? What are they going to do? So, whenever you are sending a message to someone, the message most of the time contains a command. So I can text you, go and cook for me. The command there is to cook. So I can text you a message like, come follow me to somewhere. The command is to follow me to somewhere. I can text you on a message that, come wash my car. The message is to come and wash my car. So I don't have one at the moment. So the point is that a message always contains a what? A command. So this medulla oblongata is sending a message through all these nerves to the diaphragm and the intercostal what? Intercostal muscle. And it's telling them to do something. So what is the command that the brain, that the medulla oblongata is sending through all these nerves to these guys? So we understand that in the next thing. So I'll be right back. Yeah, welcome back. Now, let's quickly draw a diagram of the respiratory system. But the point is, it won't be big this time. We don't need it big again. So I'll quickly do that now. Now, we said the mechanism of respiration, the inspiratory phase. We said the oxygen level is reduced. And we said this blood vessel can either be the arc of aorta, or the what? Or the carotid artery. And then we said we have some receptors on it. And those receptors are called the chemoreceptors. The chemoreceptors. And we said that function is to take an impulse to where? To a part of the brain called the medulla oblongata. And then we said the medulla oblongata will respond by sending an impulse through some nerves. So we said one of those nerves is the what? Is the intercostal nerve. Intercostal nerve. So we said the intercostal nerve is going to act on the what? It's going to act on these intercostal muscles. And we said it will send an impulse again through another what? Another nerve. And that nerve is called the what? The phrenic nerve. Phrenic nerve. I would say the phrenic nerve is acting on the what? On this structure here called the diaphragm. The diaphragm. Now, what will happen to these guys? We said if you are sending a message, the message must contain a command. So, what is the command that this medulla oblongata is giving to this what? Is giving to this intercostal what? This intercostal muscles. These intercostal muscles. And the what? And the diaphragm. What is the command they are receiving? The command they are receiving is to contract. To do what? To contract. And when these 2 muscles, when they contract, they are going to bring about a single thing. And that thing is expansion of the thoracic cage. Expansion of the what? Of the thoracic cage. Expansion of the thoracic cage or thoracic cavity. Now, what's the meaning of that? When this intercostal muscle and this diaphragm, when they contract, what they do is that they are going to expand. Expand means to increase the what? The thoracic cage or thoracic cavity. I've told you the thoracic cage is your chest. So that is what happens in the inspiratory phase. So when you breathe in, notice yourself. You see that your chest, it moves up and outward. And then all this place will be painful if you are breathing too much. It's because they are also expanding as well. Now, the question is, how do they what? How do they expand? It is normal for us to say, this intercostal what? This intercostal muscle is going to expand laterally, like this. it will expand to the side, like it will expand like this. So, and this side and this side in anatomy is what? Is laterally by the sides. And apart from that, you realize that this thoracic cage moves upward and outward. So it means it's going to increase what? Anteriorly, which means outward like that. So that's an anatomical term. Another anatomical term wider. We have laterally. So and what? Anteriorly. But it's not going to increase outward again. Alone rather. It's going to increase posteriorly too. And that is to the back, posteriorly. And that's another anatomical term. So this intercostal muscle, they are going to increase or expand the thoracic cage anteriorly, laterally, and what? And posteriorly. But this diaphragm, what is it going to do? I told you that the shape of this diaphragm is what? It's dome. And now, from this dome, it's going to contract. And when it contracts, this shape will change from this nature into this. That is, from dome shape, it's going to change into what? Into flattened. It's going to change to flat. So, to flatten out. Now, let me ask you, will this flatten out? Will it increase the volume of thoracic cage or decrease it? Let's take a look at it. Now, you have something of this nature now. So this is a jar, for example, now, where you can pour water or where you can keep anything. Let's assume that you can keep 8 balls inside this jar. 1, 2, 3, 4, 5, 6, 7, let's say 8. Now, they told you to move down this part, to press it down a little bit, and the jar becomes like this. Tell me, if this jar A, if it contains 10 balls, how many balls? Sorry, 8 balls. Sorry, 8 balls. So how many balls will this jar B contain? Obviously, to contain more balls than 8. You can see now. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How do you get that? It's going to contain what? 14 balls. Which means the capacity it can hold. The volume, let's use that. So the volume of this jar has increased. Whereas this one, the volume decreased. So that is the meaning of volume. Volume is the amount of things something can contain. If I have a cup now, this cup here, and then I have another cup here. So the bigger cup will have the higher volume. Which means if this cup is A and this cup is B. So the cup A and cup B, which one has the higher volume? Cup B. Because, cup B will have a higher volume, increased volume. Simply because it is bigger. It can contain more things than what? Than this cup A. So the volume of this cup A is what? Is low. As simple as that. Which means this diaphragm is going to respond to the message of what? The medulla oblongata. By what? By changing from its dome shape to what? To flat. And tell me, how does it increase the thoracic cage? It increases it downward. And downward means what? Inferiorly. Inferiorly. As simple as that. Now, if you take a close look at all these terms, I told you that this intercostal muscle, they are going to move upward, outward. Upward is superiorly. Superiorly. You realize that all our anatomical terms in the 4-dimensional areas is complete. So you have laterally, that's by the side. So superiorly is what? Up. Anteriorly is what? Front. Posteriorly is what? Back. And inferiorly is what? Under. So these two muscles, what they do is the expansion of the what? Of the thoracic cage. So they've increased the normal volume of the thoracic cage like that. So if this is the normal size of the thoracic cage, this is that. Normally, the diaphragm is this dome shape, pressing against the what? Pressing against the lungs. And then this boundary will be the what? Intercostal muscle. So here the intercostal muscle has expanded, and then the diaphragm has flattened. Which means they increase the what? The volume of the thoracic cage. And that's the meaning of the sentence here. I hope you understand that. And that is what you have to know. And now, I would like to chop the board and talk about a law in physics. And that is the Boyle's law and the law of diffusion of gases. But before that, let's do a quick recap. We said in respiratory phase, reduction in the level of oxygen will cause what? Reduction in the level of oxygen is going to what? It's going to make the chemoreceptors on the carotid artery and the arc of aorta to fire an impulse, to send an impulse to a control center called what? The medulla oblongata. And that is one of the respiratory centers. And then we said, this medulla oblongata, it will regulate the impulse. That is the first thing. The second thing is that it's going to send impulse through what? Through the intercostal nerve. To where? The intercostal muscle. And through the phrenic nerve. To where? To the diaphragm. And we said, these two guys, they are going to what? They are going to contract. And when they contract, they are going to expand the thoracic cage anteriorly, posteriorly, laterally, and superiorly, and inferiorly. As simple as that. If you want to group all these terms, you can say superior inferiorly, comma, anterior posteriorly, comma, and laterally. As simple as that. Which means the volume of the thoracic cage has increased. Now, let me tell you something, okay? That's the voice club. I'd like to go to the board and come in with it again. I'll be right back.